Section 4, Scale Factors, Example 2. So here we're given similar rectangular prisms. Now we talked about ratios in our first example. Scale factor is where we ended up going with that discussion. So now we're getting right to the point. What's the scale factor? Now in this case, there is no direction required, so I'm just going to go left to right. That's my direction, which would give me 5 over, and you got to figure what matches up with that, and that'd be 25. Now again, scale factors are reduced. Before it was just a ratio. We chose to reduce it, but we know that in reducing your proportion, you're going to get a scale factor. So in this case, we get 1 over 5. That is your scale factor for these two shapes. Now we're going to talk about surface area. Now notice the piece area in the statement surface area. We're still talking about area, so the units are going to be squared. So we're going to look at our relationship between surface areas and so on. In this case, there's lots of work to be done here. Surface area, if you remember, for prisms is the sum of all the faces of the shape. So in this case, by longhand, and I'll do this relatively quickly here, it's a lot of busy work, but just for review purposes, surface area for the first one would be found by taking 5 times 16, which would be the surface area of the front face. We take 16 times 3, which would be the comparison for the bottom, or the numbers for the bottom. And then we would take it 5 times 3 to get the last side. These products are 80, 48, and 15. Now the thing is, that's 3 of the sides. You have 6 total sides on this shape, and you're duplicating all of these. So I would just take it each one times 2, because you have basically another side matching with that. And that would give you 160, 96, and 30, which adds up to 286. Now we don't know inches, but it is squared. Units squared. We don't know what units. So the next one would be done the same way, and I'm not going to do this one by hand. I'm going to just tell you that the surface area of this shape would come out to be 7,150 units squared. So the ratio of areas, of surface area, would be 286 to 7,150. And if you reduce that, you get 1 over 25. And that is how they would compare. So a ratio of 1 to 25. If you look at volume, if you remember, again I'll focus on the first one. Volume is length times width times height, so 16 times 3 times 5, which is 240. The other shape, same calculations, would give us 30,000. So a ratio of volumes would be 240, sorry for the pause there, over 30,000. And if you reduce that, you get 1 over 125. Now remember, in units, volume are cubed. All right, so when we look at the 3 results we got here, we have ratio or scale factor of 1/5, which is a ratio of length. Okay. If we square it, we get 1 over 25, which ended up being the ratio of areas. and I'm not going to do this one here. I want to rewrite this. If we instead cube it, we get 1 over 125, the ratio of volumes, all coming from our scale factor. And that will come into play later in our applied questions. And this ends the video.